platform, which is an AI framework that I've been working on since 2017, and I think this really has a lot of power to, catalyze the emergence of more and more intelligent systems that can apply across many different vertical markets. It's not the first thing I've done in AI, but I'm hoping it's going to be the most impactful. So I've been working on AI in various forms for, I guess, more than 30 years now. And I meet many people who are surprised anyone's working on AI for 30 years. People think AI was invented 4 or 5 years ago. Actually, you could date it back at least to Norbert Wiener's work on cybernetics in the 1930s. And then the term AI itself emerged in the late 1950s in an AI workshop at Dartmouth College. But I would say, when I started working in the AI field in the 1980s, there were a lot of really good ideas, but not that much that worked really spectacularly. I mean, there were already interesting things in the 1960s. For example, AI could beat the human champion in checkers, right? And we had AI the first time that could do calculus problems and algebra problems, which now we consider routine, but was amazing at the time. And you had AI medical diagnostic systems in the 70s and 80s that could diagnose many diseases better than human doctors. So, and you had unmanned automated vehicles in U.S. military back in the 80s, 90s. So what we see now in terms of everyday AI applications that are right in our faces when we're using the internet or out in the street, all these things were there already in 70s, 80s, 90s, even before, but they were more obscure. They were more expensive. The functionality was more brittle and special. Now, what we've seen in the last, say, 2 to 5 years is due to having more and more powerful computers, more and more available data, cheaper and cheaper sensors, more connectivity among the different computer systems on the planet. We're seeing that AI is advancing at a much, much faster rate than before, and it's become something that everyone sees. Like you can't avoid it. You go online and you see, I mean, face recognition is capturing people's faces on the internet. You can translate one language to another moderately well, very well for some language pairs through free services. You can see autonomous cars driving down the roads in various parts of the world. So now we're seeing what previously was inside a few special applications in government agencies or big corporations or hospitals or Wall Street firms. We're now seeing AI everywhere, right? And the number of AI startups just around this conference it's amazing. Since I can remember when, I mean, you could count the AI startups in the U.S. like on the fingers of your hand, really. And this is an interesting opportunity in a variety of different ways, because the AI ecosystem as it is now, it's amazing, but it also has some key shortcomings, and then one can think about how to overcome them. So one shortcoming we have now is AI is still very narrow. So the way I think of it is we're in the middle of a narrow AI revolution, meaning we now are seeing AIs that can do very special things in a variety of domains very well. And I mean, it's really interesting. These AIs doing very special things can be very valuable. We still haven't gone full on into what I think of as the AGI revolution, meaning AIs that have general intelligence, more like people have, that can really learn and reason in a way that lets them go far beyond their training data and far beyond their experience. Like I can operate this device and so can all of you, but I didn't learn it in school, and certainly the ability to operate a smartphone was not coded into my genome, right? So we're able to deal with devices, context, situations very, very different than what we were taught programmed for or biologically built for. Right now, AIs stick a bit closer to their programming and to their training data. Another limitation of the modern AI ecosystem is connectivity. So we have all these narrow AIs, but the narrow AIs doing highly specialized things are not connected together into an overall AI network. So if you look in a hospital, for example, you might have one AI that helps the hospital optimize its expenditure. You might have another AI that reads scans to help with radiology. You might have another AI that analyzes multi-channel EEG data. You might have another AI that looks at genomics data, another AI that looks at clinical medicine data to decide when people should go back to the hospital. Typically, these different AIs, you might have a different AI doing smart power grid management on the power grid that enmeshes the hospital and the city's power infrastructure. Right now, these different AIs, they're trained in their specialized ways, and they're not all connected together, right? And I think these two shortcomings of narrowness as opposed to AGI and disconnectedness as opposed to integration, they're associated issues. So I think that part of the path from narrow AI to general intelligence is going to be about connecting together disparate AIs into more tightly connected networks. I mean, that's not the whole answer. I don't think you can take a bunch of very narrow systems and connect them, and then magically a general intelligence will appear. But I think that taking a bunch of narrow systems and a few systems focused on generalization and abstraction and connecting them all together, you're going to get general intelligence in this emergent network. Somewhat as the human brain and body consist of a few components very good at generalization, and other components that are very specialized, like dealing with movement or sense processing and so forth. Finally, one other issue with the current AI scene, as exciting as it is, before I launch into the specifics of SingularityNET, there's a small collection of parties, mostly large companies, a couple large governments, that are controlling most of the AI on the planet, most of the processing power, most of the data being fed into AIs, and hiring most of the AI researchers. And I mean, this is not bad in every way. I mean, companies like Google, Alibaba, Tencent, Microsoft, they're doing amazing things. They've made many breakthroughs, and they're making many valuable services that we all use every day. On the other hand, they're focusing on a fairly narrow selection of applications in accordance with their particular business models, which means that other AI applications, let's say education or health or automating engineering design, applications that don't match the business models of these large corporations are getting less love and attention than they perhaps should be getting, right? And so SingularityNET, which I'm going to talk about now, this originated as a desire to address all these three problems: narrowness, disconnection, and oligopoly. SingularityNET originated as it's a way to connect together many different AIs in an infrastructure based on principles of decentralized control and organization, with a view toward delivering, high-quality AI services for many practical applications, and also toward allowing multiple different AIs to combine together to form an emergent general intelligence. And that's a big, hairy, audacious goal, as they would call it. It's a big, crazy vision. We're partway there. We haven't achieved all of our goals, or else you'd be seeing a super intelligent, cloud-connected robot up here talking instead of just another meat-based biocomputer. But we have gotten partway to implementing what we set out to with SingularityNET. And what I'm going to do in the next half hour or so, I'm going to walk you through mostly what we've built, so far with SingularityNet. So I give many different types of talks on SingularityNet. The talk I gave yesterday in a different section of this humongous GITEX megalopolis. I mean, the talk I gave yesterday was more focused on different vertical applications we're doing with SingularityNet. I talked about some biomedical applications, some smart city applications, some robotics applications. In this particular talk, I'm going to go in more depth through some of the nitty-gritty sort of plumbing of what we've built so far with the decentralized platform. And some pieces of this will look a bit obscure to those without computer science or software engineering background, but hopefully it'll be interesting in giving you a view into how you actually build something so big, crazy, and ambitious as this. Because I mean, in the end, you can go around and talk all you want about democratizing AI and having general intelligence emerge, but actually, structuring the software objects to achieve this is another thing entirely. So, yeah, the very high level, what we're building here. It's on. I don't have a secondary monitor here. I'm looking at the same screen as you guys. At the high level, what we're building here, it's a network. It's a network connecting AI software containers that perform AI processes on data, which are AI agents, as we call them, users of AI, and developers of AI. And we have a network where the nodes are AI developers, users are AIs themselves, AI agents. And part of the notion with decentralized control is there's no central ruler of this network, but rather all the nodes in the network together have to vote and coordinate to regulate how the overall network operates. So I mean, we're looking at a network involving many different participants, right? So I mean, you need AI developers, you need people to help build the platform, we need companies using the AI on this platform, individuals and entrepreneurs using the AI on the platform, people building software applications that make API calls into the AI agents on the platform. And really, you need a whole ecosystem of participants in different roles to pull something like this off. All the participants in this ecosystem are operating in the context of a quite complex software stack, right? So the AI agents themselves, you see the AI algorithms in the middle there, I mean, these are running on some infrastructure, right? It could be Amazon AWS, Alibaba Cloud. I mean, it could be our own server farms with our own Kubernetes-based infrastructure and so forth on it. It could be some more radical infrastructure with components on, different phones and home computers. And we have a project called NewNet that's working on this broader infrastructure with multiple devices. Then, on top of the core AI algorithms, you need end user products that make API calls to AI algorithms that provide specific services to end users. And then we have a marketplace in which a cryptographic utility token, the AGI token, is used to pay for services. And as we'll go over later, the token is used inside the network. So if one AI wants to outsource work to another AI, it pays in this token. End users can also use the token, but we also have interfaces where you can pay with regular money for AI services, and then the token is just something that's there on the back end. And we'll go through these details a bit later. But the use of a cryptographic token for payment and exchange among the AIs is part of what we've done to enable a purely decentralized and secure infrastructure in a way that's efficient and legally compliant. So now the blockchain here exists really at the lowest level. I mean, an AI agent is, for those who have a technical background, I mean, an AI agent is basically a Docker container or LXC container, which has some software code running in it that supplies certain APIs to the outside world, and then to integrate your AI code into SingularityNet, in that container, you put some SingularityNet code that allows receipt of payment and secure transmission of simple data across certain channels, and it broadcasts your identity to the rest of the SingularityNet network. So the blockchain is really there for messaging of certain types between the AI agents in the network, and for payment and verification of identity and reputation rating. The AI processing itself doesn't happen on the blockchain. That would be very, very inefficient given current blockchain technology. So the AI's own thinking is not on the blockchain. The transmission of huge data sets is not on the blockchain. The coordination of the different AI agents and their basic level of communication is on the blockchain. So yeah, we have agents that provide AI services, and each service has APIs that it can fulfill. We have smart contracts, which is part of the blockchain infrastructure, and like most smart contracts, these aren't very smart, and only some of them are actually contracts. But I mean, the smart contract is more of a persistent script using secure messaging to enable transactions between different agents. Like, okay, I'll pay you X amount of tokens or dollars if you classify these images for me, or I'll buy 10,000 question answering query calls per month for the next year for this subscription price or something. So we have a variety of smart contracts allowing various economic relations, either between AIs or between end users and AIs. And there's a software object called the daemon, which is a term coming from the Linux world. So there's a software agent called the daemon that has wrapped up in it all the interactions with the blockchain. So, I mean, we built the first version of SingularityNet using Ethereum blockchain, but if we threw that out and replace it with another blockchain, or if we supplement Ethereum and make it multi-chain, that affects what happens inside the daemon object, and it doesn't require anyone to change their AI code. The AI code will operate the same way no matter what underlying blockchain is being used. So, as we're operating this right now, we're just getting started. I mean, there's dozens of AI services on here, not thousands. We have a common registry that just has a list of all the AI services on the network. And so if you want an AI to do a certain thing, you can search through that registry and see what services are on there and what they do. Now, down the road, you could actually have multiple registries, right? And I mean, you could have a registry, say, for European users that has only GDPR compliant AI services on it. And you could have another registry that had a wider collection of things on it. So in that sense, you could view it as a meta marketplace rather than just a single marketplace. I mean, a decentralized network you could think of as being more like BitTorrent network or something, right? It's just anyone can put something on there, no matter where they are in the world, and broadcast that they're there, and then the other nodes of the network will be able to communicate with them and find them. And that's purely decentralized and peer-to-peer, just like the internet is, right? Anyone can put something on the internet and send TCP/IP messages around. On the other hand, if you make a registry of agents and say a marketplace user interface back-ended on that registry, then you, as the maintainer of that registry and marketplace user interface, you're taking some legal responsibility for the AIs that you list there, right? So like in Europe, if you list a bunch of non-GDPR compliant services, you could be liable for that in some jurisdictions. So you could have, in the end, anyone could put an AI into the network, and then you could have multiple registries, each listing a subset of the AIs in the network. Right now, we have one registry and one central marketplace because we're just getting started, right? And so we have a marketplace DApp, meaning a decentralized app, like a blockchain-based app store. We have one marketplace DApp where you can go and see what AIs are listed there, and we have a SDK, software development kit, that developers can use to integrate their AI code with the platform. And one of the things we haven't done that much with yet, but which I think is key to the whole vision. One of the cool things about here is, AI agents can call other AI agents, or AI agents can create new AI agents, right? So you could have an AI doing video analysis, where if it wants to analyze the voice in a video, it outsources that work to another AI doing voice analysis. And you can have an AI that's doing natural language processing, but if it gets confused about something, maybe it wants to look at the phonology of the words, it can go to that voice analysis agent also. So you can have different AI agents that all outsource work to each other in different contexts. You could also say have an AI agent that studies a bunch of video, and from studying that video, let's say it learns a model of recognizing when a robbery is happening, right? Then it could create a new AI agent, which is just like a crime recognition AI agent. So you can have an AI agent creating other AI agents. The simplest example of which is an AI agent containing a learning algorithm that learns models on data and creates another AI agent embodying the model learned on that data. And these more advanced aspects of the network we're playing with on the research side. They're not being used much in practice yet, but I think that's really where the crux of this design is headed, because if we want to have a whole bunch of AIs in this distributed network, and they're all outsourcing work to each other and sharing information with each other and coordinating together, it's these sorts of capabilities of AIs creating AIs and AIs talking to AIs. This is what will let the whole network of AIs ultimately display some emergent properties. And I'm here focusing mainly on SingularityNET, this decentralized platform, but I wanted to add, we've also created a spin-off company, which is a for-profit company called Singularity Studio, which is just building enterprise software applications for big companies, where what the company sees is something that does, say, traffic analysis or medical clinical trial analytics or some risk management, some highly specific function. But on the back end, the enterprise software product is making API calls into this decentralized AI network. So the idea is, for a developer / entrepreneur or a computer hacker or a small startup, they may want to just go directly to the AIs in this decentralized network. I mean, it's low cost and very diverse. Large corporation may not know how to deal with this decentralized blockchain-based network, but if you give them a product doing exactly what they want, and it gets its AI on the back end from API calls into this network, then that can work. So we have SingularityNET beta platform is live. You can play with some of the AIs on it now. The 1.0 is not there yet. There's still features that we're adding, but the beta works. It's scalable. It's reasonably efficient. You can actually put AIs on there and sell their services to people. What I'm going to go over now in the rest of this talk is some of the details of how this marketplace actually works. But yeah, let me first get a better sense of exactly who I'm talking to. So, how many people, raise your hand if you are a software developer. Raise your hand if you have never written a computer program in your life. Have you written a computer program, David? Yeah, yeah, all right. Yeah. So, all right, we have some developers here, but not a completely developer full audience. So I think some of the slides here are going to be kind of in depth for non-developers, but I'll try to keep everything simple, because this was sort of, it was presented to me as like an in-depth, hands-on type workshop, which is not exactly the audience here. But on the other hand, I think even if you're not a developer, it's cool to see a bit of what's actually happening behind the scenes. So this is an architecture diagram showing some of the different pieces that we needed to build in order to make this happen. And honestly, it wasn't very easy to make a blockchain-based decentralized system actually function reasonably efficiently in a way that people could use it for AI services. And we had to do a bunch of complicated things. So there you see there's like IPFS, blockchain-based file system. We have a multi-party escrow smart contract, which allows all the different agents and customers and providers involved in the transaction to manage the cryptographic tokens involved in the transaction. So say if I'm going to pay you for a transaction, but I didn't get the results yet, you still want to guarantee that if you deliver the results, you'll get paid, right? So there's some escrow provided in the smart contract, but then maybe someone else has been nominated to double check that you actually delivered the services, right? Or if I say your answers weren't good enough, but you said they were good enough, maybe someone else to mediate that, then that party is involved in the escrow arrangement also. But given a smart contract-based system, all these relationships have to be put in code so they can be conducted automatically by AIs, which means a bunch of multi-party escrow smart contracts. But at the same time, we wanted the AI to be able to run the same way, even if we change the underlying blockchain, so it becomes like a blockchain agnostic design, which meant we had to pack all reference to the blockchain inside the daemon, and the daemon with storage replicas, because we also want to be able to change what we use for storage. Like, is it IPFS, or do we use an ocean protocol for storage, or what, right? The daemon should be the same regardless of whether you're changing what underlying storage fabric you're using. So there's a lot of layers of abstraction here, the goal of which is when an AI developer puts their AI in the Docker container and puts it in the network, the AI should just keep doing whatever it's doing, even if we change, what backend we use for storage, what blockchain we use for communication and security and so forth. The AI should remain the same. And you don't want the access of services or the interaction of AIs to be slowed down more than you can help by any problems with the underlying blockchain. Like if you use the Ethereum or Bitcoin blockchains at all, you'll experience, like, sometimes it can take minutes for an Ethereum transaction to finalize. It can be quite a pain. Like if I want to send someone some Ethereum tokens, it could take 5 minutes till the little website I used to do that tells me the tokens have gotten where they're supposed to go. On the other hand, I don't want it to take that long for two AIs to be chatting with each other, right? So part of this design is about working around the crappiness of the underlying blockchain technologies now. So as one part of that, we have a whole bunch of what we call channels that open up between different AI agents and communication channels. So that once a user or an AI agent first makes contact with another AI agent, they exchange identities, they verify who each other are, and they set up a number of secure communication channels between each other. And then after that, communication can go back and forth across those channels forever, as long as those guys are still on the internet. So the only slow thing here is establishing connection between two agents for the first time. And that happens at the speed of the underlying blockchain. And we're looking at ways to speed that up, which I'll explain a little later. But once the connection between two agents is made, then a bunch of channels are set up between those agents, and everything can occur rapidly along those channels. I mean, one of which is a payment channel, right? So once we've made a connection and we've validated each other's identities, then we can do many transactions between each other on this payment channel. Those don't need to go on the underlying blockchain; they're just in SingularityNET's code. Then those can be very fast. And the registry contains all the information about all the AI services in the network. As I said, you could ultimately have multiple registries, each of which has information about some of the services in the network. And this is also, it's stored off the blockchain in IPFS, but in a secure way. So you can go to the registry and find out, for example, what AI services can each agent do. So there's sort of two ways that the search could work, right? If I want to find an AI that can answer medical questions, the basic way to do it in this sort of decentralized network is purely peer-to-peer. Like, I ask everyone I know in the network, hey, are you an AI that can answer medical questions? Are you an AI that can answer medical questions? How about you? If you're not, ask all your neighbors, or any of those AIs that can answer medical questions. And eventually, through peer-to-peer messaging, you'll get to everyone in the network, and indirectly all the AIs that answer medical questions will get to me. Right now, the more efficient way to do it is you have a registry which does that spidering for you. It periodically looks at all the AIs in the network and makes a list of what functions they can each do. Then I can just go to that registry and say, hey, registry, what AIs that can answer medical questions do you know about, right? Now the registry in itself is centralized. On the other hand, it's built on top of this underlying decentralized network, and you could have multiple centralized registries. So if all the registries were wiped out, it would be a temporary problem, but they can always be reconstituted from the decentralized network. So it's sort of, again, it's a bit like BitTorrent, right? Where the torrent nodes and servers are all in a decentralized network. But you could also, in an interface, you could see a list of torrent servers. It's not guaranteed to be 100% correct, and it could always be rebuilt from the underlying decentralized network. And yet this digs in more detail than I'm going to do, given that the audience isn't that technical. But the multi-party escrow contract, it's a crypto wallet, and it's a bunch of different payment channels, and these are all made to work together to allow this, AGI token-based transaction to happen, including complex cases where you have an adjudicator or a mediator for the transaction between two agents, or an agent goes offline and comes online again, and so forth. Because basically, we can have no central clearinghouse or no central bank or something for all the economic transactions between the different agents in the network, but you need to encompass various possibilities for different agents or mediators in the network, right? Because if you're going to do some AI services for me, how does the payment work? Like, do I pay you first, and then you give me the services? Well, then what if you don't give me the services, right? Or do I get the services first, and then I pay you? Or what if I don't pay you, right? Well, okay, so we can agree that a certain third party can be there to validate that the services are okay. So then what I do, I give the money to the third party escrow agent. Then when I say I got the services, the escrow agent, releases the money, right? But all this has to be just on the level of software and fully automated. And that's what the multi-party escrow software does. And then now we have user interface you can find on beta.singularitynet.io, and the user interface, it lists a whole bunch of the AI services that are on there now, and lets you connect to your Ethereum wallet so you can pay for the services with the AGI token. And within the next month or so, we'll finalize integration with PayPal, which will be a big change, because then you can pay for the AI services with your PayPal wallet that you fill up with money from your bank account or credit card, which means you don't have to be part of this sort of Ethereum or cryptocurrency ecosystem to use it. Because basically, PayPal's APIs let you use PayPal for Bitcoin or Ethereum transactions. And then once you're in the crypto world, you can convert Ethereum or Bitcoin to the AGI token that's used here. And I think that certainly that's one of the things we need to get from beta to 1.0, because the cryptocurrency-based foundation is really good for allowing decentralized operation that runs across all jurisdictions. You don't need a central controller. On the other hand, in practice, to get widespread adoption, not everyone who needs AI services wants to pay with some weird ERC20 utility token. You need to just let them pay with regular money and let the token exist on the back end. So there's the way I usually interact with this is using the command line interface, just being an old style Linux guy. So I mean, I'm not going to go over all of this now, but I mean, you can type on the command line in the Linux shell. You can do a bunch of things. You can create a new agent, create a new organization that owns agents, set the price for a certain service. You can tell the location of your agent. You can specify this description of what the agent does. Check how much money you've been paid in the network. You can invoke a service, and so all these different operations with the channels between agents and the creation of agents and organization of agents. This can all be scripted, right? And so this is really the power of smart contracts, right? Like we're creating this whole economy of AI agents that can all talk to each other and sell things to each other and provide each other services. And this whole society of AI minds, I mean, you can just create it by a bunch of command line Linux scripts, right? It's like script your own AI economy. And what makes it all possible is a software object called the daemon, which mediates the interaction between the AI and all the smart contracts and the payment channels and the storage and so forth. So, I mean, if you create some AI code, you put it in, say, a Docker container, and then the daemon is also running in the Docker container with what's called like a sidecar proxy design pattern, and the daemon runs alongside your AI that handles all the interaction with this network. So if we upgrade the daemon, that we can upgrade the daemon to involve a different blockchain network or different storage or something. The AI code remains the same, and you can type things on the command line, or you can send messages across a socket or whatever, which is what you do with a software development kit, which will. Right now, we have JavaScript and Python, C++, and Java are coming soon. So one of the more interesting things that we're going to launch in the next month is a request for AI portal. And this sort of stresses the cryptocurrency ecosystem part of what we're doing a bit. The idea here is, suppose I want some AI to be in the network that isn't there right now. I can say, well, I'll give 100,000 AGI tokens. I'll give a certain amount of payment to the first person or AI who puts an AI doing this thing in the network, right? So say I want an AI algorithm that will recognize pigs' faces, for example, because I'm a pig farmer. I want a camera that'll tell if all my pigs have come in their enclosure at night, right? So no one has put pig face recognition on SingularityNET platform yet, but I'll pay 100,000 AGI tokens for the first person to put it on there. So I can post that on the request for AI portal. Then either either I can post an automated test that will validate if anyone has put an AI agent that can do pig face recognition, or I can say, well, I'll nominate like these 10 agents, and if they all validate that this code does pig face recognition correctly, then the funds come out of escrow and the payment will be released. So you have smart contracts to specify the criteria for validation of solutions. And I think this can be an interesting way to grow the network. And of course, everything that happens in the network that humans can do, AIs could also do, right? So initially people are putting requests for AI on the portal, but AIs could also do that. If an AI identifies it needs a certain sub-service that isn't being offered on the network, I mean the AI itself could put a request for AI on the portal, and it can then send tokens to another human or AI that had created something fulfilling the specified criteria. And yeah, I think that's going to be quite interesting. The PayPal integration, I already mentioned, that should be there quite soon. Now, I mentioned we're using Ethereum here. I mean, Ethereum Solidity language for smart contract development I view that as a great rapid prototyping tool. I mean, using Ethereum let us get this whole thing up and running, which was actually quite difficult and took a year and a half or something. On the other hand, Ethereum network is still very slow and has some pretty bad underlying design flaws. The Ethereum community is trying to remedy those design flaws and make Ethereum faster and more scalable. On the other hand, we're now experimenting with a version of SingularityNet that uses a different blockchain infrastructure called TODA, T-O-D-A, which I think you'll be hearing a lot about this fall. And so far, TODA is very fast and scalable compared to Ethereum. I mean, we're still doing more testing, but at the moment, my intuition is this is a very good way to go. So what we may do is make SingularityNet daemon multi-chain, meaning you could have some AI agents using Ethereum and some using TODA, and then just allow swapping between the AGI Ethereum tokens and AGI TODA tokens. You don't need to have just one underlying blockchain. You can have it operate on many, and then of course, if it happened that TODA really works out cheaper to use and faster, then more and more network participants would end up wanting to use that, and it would gravitate in that direction. So I think we knew when we founded this that Ethereum might not be the solution for all time, which is part of the reason we encapsulate all the blockchain interactions in this daemon object. So we're creating a publisher portal that makes it easier for AI developers to put their AIs in the network. Now you can do that, but only through the command line interface. But we want a simple web portal for people to take their AI tools and just insert them into the network. So if you go to the beta website, I mean, you'll see a list of a bunch of the AI services that are on there now, and you can click on each of them and get it to do some simple things like this. This is an example of a text generation website which uses some transformal neural networks just to generate text that's trained on various different models. So yeah, we have a Trump simulator on there just for fun. That was one of the easier ones because the level of complexity of the language is not that large. Now, I'm working with a humanoid robot called Philip K. Dick, which is from Hanson Robotics. So this is sort of the Sophia robot's brother. I worked for several years on Sophia, which is really the world's most realistic humanoid robot. Philip K. Dick robot, made by the same guy, David Hanson, at the same company. Not quite as many motors in the head as Sophia. In some ways like him better. I think he's got more gravitas to him somehow. You can find videos of him online. But we're using SingularityNet's text generation service to generate new stuff for the Philip K. Dick robot to say. So we fed it a whole bunch of Philip K. Dick's diaries and philosophical writings and essays, and then just told it to generate new Philip K. Dick-like philosophical dispositions, which the robot will then utter. And yes, some of them are not bad. I think they make as much sense as his own philosophical ramblings anyway. So maybe the text generation service on the SingularityNET beta will discover secrets of the universe or something. We also have a service which does gene annotation, and this is one of the things that's closer to my heart, the use of AI to analyze biology data and genetics data. So for example, we've been using this and some other AI services in SingularityNET to analyze DNA data from people aged 105 years or over. And we've discovered some very cool things. Like they have a lot more genetic mutations than ordinary people. And they have mutations specifically in a certain complex of genes that starts acting differently in most of us at age around 60. So in most of us, there's a change that happens in the expression of a complex of 800 genes around age 60. But these genes act very differently in these 105-year-old people. And this is very interesting to look at the DNA of these long-lived people using AI tools. So we've wrapped a bunch of the AI tools we use for that in SingularityNET platform. So I mean, you can look up related research papers, and when you identify genes as important for analyzing some genetic data, you can connect the genes you identified as important. You can say IGF-1, say that gene popped up as important in the longevity of these supercentenarians. You can then use the gene annotation service as one example on SingularityNET platform. You can use the gene annotation service to see the relation between that gene and various other pathways and systems in the body. So, I mean, this particular service is only useful while people doing bioinformatics or medical analytics. But I mean, going back to the broader points I was mentioning at the beginning of this talk, there's a very wide scope of possible applications of AI technology, right? And it's not just about advertising and face recognition. I mean, it's also about genetics. It's about smart agriculture and identifying crop disease. It's about automating math theorem proving. There's so many things you can do with AI. And part of the value of having this sort of decentralized AI network is you can get this long tail of AI applications, and some of these long tail applications are really important. Like, if we understand how these supercentenarians live so long, I mean, maybe we can make a longevity pill that will prolong all of our lives. So, yeah, I'm about done here. We're out of time. I just want to mention one final point in the last minute, which is to make all this work without a centralized controller, a very key ingredient is the reputation system. Because, I mean, as we all know as internet users, when you make an open platform where anyone can put something into it, there's going to be a lot of stuff in there that may not be very useful or intelligent in any way, right? And, I mean, one way to control that is like Apple's App Store, where you just have some gatekeepers, right? And another way to control that is to have a decentralized reputation system where the users in the network rate each other, and they also rate the raters, right? And you need to work out the math so this decentralized rating can all balance out without any central gatekeeper. And that turns out to be an AI problem in itself. Like, identifying reputation fraud in a rating system itself is a machine learning problem. We've put a bunch of work into that. We published some papers on our weighted liquid rank reputation system, and integrating that into the platform is another thing we're doing this fall. There's a whole bunch of components inside the reputation system, including the Wi-Fi connection into the brain of Anton Kolodin, who developed the reputation system. So, obviously there's a lot of different pieces here, and I've only sort of sketched a few of them, but yeah, I'd like to encourage everyone to get involved with this in whatever way makes sense in terms of your own skills and backgrounds. Certainly, if you're an AI developer, we're very interested to have more AI developers code into the platform. If you're a blockchain developer, this is all open source code. We can use more help just to create this decentralized AI infrastructure. But if you're involved with companies, government agencies, and so forth that are using AI, I mean, we have Singularity Studio, which is doing custom AI development and selling AI products back-ended here. But I think really there's not much, in my view, that's more important to humanity today than ensuring that as we transition from narrow AI to general intelligence, this happens in a democratic, open and participatory way. And this is it's a very high-falutin philosophical idea, but to make it actually work, there's a lot of nitty-gritty software engineering and AI application development that has to be done, and we're trying to pull together as large and diverse a community as we can to help us work toward this goal. And thanks for listening.
Thank you so much. I don't know about you, but I felt like I was listening to a master designer, master mechanic explain the workings of a supercar. But it wasn't just a supercar, it was the artificial intelligent universe inside of our universe. So thank you very much. That was really, really cool. Now, I want to introduce our next speaker.